I'm David Paulus. This is a Nautilus Smith machine with constrained linear motion for free weights, and it's been changed over to a pneumatic system where it has a pneumatic cylinder that provides the air resistance by changing the pressure. The pressure is controlled by a proportional pressure controller. The goal for the system is to be able to control the pressure and thereby control the force of the person interactively as they move up through the stroke. The pressure in the cylinder, which acts as the resistance, is controlled by a LabVIEW and a data acquisition card. There's a linear position transducer on the side of the cylinder, and how that's read is there's a magnet on the piston that records the magnetic field into this rail. What the position is sent to a processor, takes the derivative of time, and it becomes instantaneous velocity. So this is an isometric test, and it's just to show that the strength the person has varies throughout the range of the lift, starting from 90-degree knee angle all the way up to 170. The knee angle is the x-axis, and the maximum force produced at a constant knee angle is the y-axis. And at a 90-degree knee angle, which is the lowest point in the lift, it's much weaker than, say, at 150-degree knee angle, where the force is a lot higher. The next set of testing after isometric is a constant resistance, where you put in a constant resistance and just measure the maximum velocity at that point. So if I put in 100 pounds, I'd lower the barbell, raise it as fast as I could, and just record the peak velocity in that lift. So we recorded one single force and a peak velocity. And then at lower forces, you can see the velocity increased in a linear relationship. So we've shown with the isometric test that the force a person can exert at each point can change throughout the range of the lift. So what we want to do is change the resistance based on how strong the person is at that point in the lift. The way we're going to change is by monitoring their velocity. If the velocity goes above a set point, they're probably strong enough to take on a little more weight, so it'll increase interactively. What the graph shows is this is the negative portion of the lift. The resistance stayed constant, and as soon as the velocity changed from negative to positive, the machine started to interact with the person, saying, based on how fast they're going, changing the resistance level. You can see as they started to move up, their velocity went higher than the set velocity, so the resistance increased, and it increased up to a point of 213, whereas it started out about 170.